Alright, so we're going to do our first practice problem on using our kinematic equation formulas. So we have a racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration using its parachute and braking system and comes to a rest 5.5 seconds later. Find the distance that the car travels during braking. So first thing I'm going to do is write out my givens. So what do I have in this problem? So a racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration. So it's going to decelerate, slow down if I have a constant negative acceleration, and then comes to a rest 5.5 seconds later. So the car goes off, it reaches a speed of 42 meters per second, and then it starts to slow down and it comes to a rest. So I start at 42 meters per second, and coming to a rest means that I'm stopped. So if something's at rest, it's at stopped. So I start at 42 meters per second. If I come to a rest, that's a 0, and that's how fast I was moving at the end of this problem. So my initial speed is 42 meters per second. And my final speed, if I come to a rest at the end of this problem, is just going to be 0 meters per second. Now I come to a rest 5.5 seconds later. Seconds is the unit for time. So I have a time of 5.5 seconds. And I'm asked to find the distance that the car travels during braking. So distance is my unknown. And notice that it mentions acceleration, but it does not give me acceleration. I don't have that as a number. So I don't have that as a given, but that does help me pick out which kinematic equation that I can use. So I have this no A formula, which means I am not given acceleration, but I am given VI and VF and T, which is here, VI, VF, and T. And then I'm looking for distance, and this one is set up to solve for distance. So I'm going to use my first equation, the no A equation, that says that displacement or distance traveled is equal to 1/2 VI plus VF times T. So I sub in my numbers. I like to use 0.5 instead of typing in 1/2 in my calculator, so that kind of helps with order of operations. 0.5 and 1/2, it's the exact same thing, but you're less likely to make a calculator that way. Plug in for VI. VI is 42 meters per second plus the final velocity, so 0 meters per second. So when I add this up, this is just going to be 42. And then we're going to multiply that by 5.5 seconds. So in my calculator, I can type in 0.5 times 42 times 5.5 seconds. And we should get that the displacement is 115.5, which I can round that up to the lowest number of significant figures, which is 2. So I can round that up to 120 meters is my displacement for this problem. All right, so that's practice problem number 1. We do have one more practice problem that I'll make a video for all of you. So if you're feeling comfortable now, you might want to try to do that practice problem on your own. See if you can get the answer, check the notes. And if you do, great. And then if you don't, watch the next practice video and give that one a shot.